Hello there, this is Chris from the Motor Solutions team at TI. I'm here to talk to you about two new things today. The first is our DRV8301 EVM, or Motor Control Kit, and that's what I've got here in blue. So this is a DRV8301. This is actually TI's first integrated three-phase pre-driver. So what this is an integrated solution that just has the pre-drive capability built into it, and you put in your own external FETs. In this case, for this board, we've put in FETs that we're calling a 60 amp board. It's actually full-scale amperage on the system is a little over 80 volts. We're calling this a 60 amp, 60 volt board. This DRV8301 is a very integrated solution, so it's got a few things different than a typical pre-driver. One is it's got an internal buck regulator. So we take the DC bus voltage that we're using for our motor drive, we actually buck that down to the 5 volts needed for our MCU interface here. And in this case, we're using a Piccolo controlCARD. We'll actually have several other microcontroller variants here from TI that we'll be putting into solutions like this relatively soon. Some more integration on the DRV8301. It's got two current sense amps built in with programmable gain front ends on them. So in this case, the solution I'm going to show you starts out without needing any current feedback, but it is nice to have current feedback, one, for monitoring your system when you're doing debug. Two, I'll show you we're actually going to use some of that current information to do some tuning of our system. But in this software solution that I'm going to show you, there's actually no current feedback that's needed. And that's because we're using an integration technique, a back EMF integration technique. So the basis for this is really looking at the back EMF voltage, typical that you would do in a standardless, sensorless BLDC solution. But what we're going to do here is, in a typical sensorless BLDC solution, you're watching for zero crossing of this back EMF on the leg of your inverter that's off. And when it crosses that 0 point, you're essentially starting a timer. And so you're waiting a certain amount of time until there's a commutation event. Then you're waiting for the next zero cross. And from that, you're essentially taking a good guess of when the next commutation event needs to take place. So you're looking back in time to make a decision on a forward event. And so if you're in steady state conditions, that works pretty well actually. But whenever you have any sort of non-steady state condition, something dynamic where you're accelerating due to a speed command or by taking a load off of the motor, if you have a torque disturbance based on putting a load on the motor, that's where these sensorless techniques run into some issues. There's also issues with the current sensorless technique when you're operating down through zero, so crossing into that low speed zero range. This technique is actually pretty impervious to that, and as I'll show you, you can go back and forth, positive, negative through zero, very robustly. So this is a very low cost sensorless BLDC technique, and it's very robust as well. So let's get started on this technique. We call it InstaSPIN-BLDC, and the thing here is that this kit actually does not ship with a motor. It's one of the first recent kits that we haven't done this with, and that's because you no longer need to have the motor that we've spent weeks in the lab tuning. This kit out of the box will instantly spin your motor. So if you're using a motor that fits within the range of this kit, which is 8 to 60 volts and up to 60 amps, we can spin your three-phase motor right out of the box. So let's take a look at how this works. This is the motor that we have been shipping previously with our DRV8312 kit. We've shipped this with our dual access kit. So it's our typical PMSM BLDC motor. This BLDC technique works with any three-phase synchronous motor. What we're doing though is controlling this in a 6-step commutation standpoint. So this isn't the sine wave FOC type control that we also have available. This first technique that I'll show you is a standard 6-step commutation, but we've implemented in what we call InstaSPIN-BLDC, which makes it very, very robust and very simple to use. And so we can spin this motor right out of the box, and in fact, we'll spin another motor as well, and you'll spin your motor at home too. So I'm going to throw on a little color wheel here just so you can see this thing turning. All I did was hook up the 3 phases. I opened the GUI that comes with the kit, and the only button I'm hitting is Enable. And so right out of the box, we're spinning here. It comes set to go to a predefined state. It's 10% duty cycle on the PWMs. But then you can go and take kind of the next steps here. So what you can do, you can see that we have some real-time graphing going on from the system. We're showing our integration threshold. So I mentioned we are looking at this back EMF on the windings on the DC bus. what we're able to do here is actually integrate this value. So we're using a fast A to D converter, and we're continuously adding up this back EMF. And so essentially what you get is a flux component. And so what we want to do is look at where the flux is essentially maximized. So what you're looking for is, as the rotor spins by the magnet created by the phases that you're energizing, you actually get that interference, that interaction that creates an EMF signal. So what we're doing is looking at where that signal is its maximum. So what we can do is we can look at adding up all of the flux that we have coming by and finding a good point to set our commutation. So out of the box, this is set at this threshold of 1. It's really just kind of a per unit number. And what we can do is we can use this to tune. So we can look at our current waveforms, and what we want to do is we want to actually minimize some of the transients in the current. We want to minimize some of the spikes, and we want to find a level where we're basically maximizing, and we're going to commutate directly when our rotor is in the right position with regards to our stator. So when I look at this, it's probably hard to see on the screen, but essentially we're commutating too late here. I can move my threshold down. So all that does is it sets the total back EMF that I'm looking at. It just sets that lower. So instead of waiting for more EMF to build up as I slide past and commutate, I've now set my bar lower, so I've added up enough, and I'm going to commutate and try to commutate right on time. So with this GUI, you can do this very easily. And once you have gone and found the right commutation point, this right threshold, you really kind of found the ideal place to be commutating. And it's really not a very fine level. You have a lot of kind of coarse area in there. And so then you're able to take the next step. So you can actually go in, you can implement a velocity loop. So we have this already built into the code as well. So you can go set a specific velocity. And when you want to start working on your speed loop tuning regulation, you can go to the settings tab. And we give you your KP and your KI so that you can automate that or tune that to your liking as you wish. After you've done that, you can stop the motor and you can add a current loop. So if you just want to use this as a torque controller, there is just a current loop setting in here. You should be careful. Remember, with just a current loop setting, you're just commanding torque. With no load on this motor, it's going to torque up to its maximum speed, or at least as much as your power supply will let it. Once you've done that, you can then cascade your loops where you can have an inner current loop and an outer velocity loop, still using the same 6-step InstaSPIN-BLDC commutation. So this is going to give you a really easy way to go from out of the box with your own motor to being able to do full closed loop control on your system. Sensorless closed loop control. As you'll notice, whenever I get a new motor, I just cut the sensor wires right off. Speed sensors are for sissies. That's the rule around here. So to give you an idea of some of the performance, just in kind of the startup mode when we're just using the commutation and no real feedback, this thing is extremely robust. So we're going here, this is really maxed out on the motor. This is 3,750 RPMs. We can go from positive 3,750 and we can swing it around here. Full negative reversal, now running at minus 2,200 RPMs. We can also run this thing a lot slower. If you want to see it slow down, it's about 1,000 RPMs. And if we want to go from a lower speed up to a positive speed reversal, you can see it's very robust. And again, get your motor and it's going to work. So just to prove that we haven't done any special tuning here on this, I'm going to go ahead and stop this guy. I am going to disconnect 3 phases, grab another BLDC motor, PMSM motor, whichever you like. This is actually the one we ship in our Stellaris BLDC kit. So I had this one sitting in the office. I'm going to show you that all I'm doing is hooking up the wires again. Haven't closed the GUI, haven't reset any code. Grab this guy. Make sure I'm not crossing my streams back here. And enable. Off we go. So this one you're going to do a little bit more tuning. This is actually a pretty low inductance motor. So what we found with these is you typically need to set the threshold even lower. I'm going to update the scaling of my system here, get some better readings. And pretty good. And we can run this one faster. And of course we can go the other speed. So you saw full speed one direction, through 0 the other way. Very robust, starting right out of the box. And with this one, of course, we can go through the next stages. We can go in set a velocity loop, set a current loop, all of that. So I'm really excited because this is going to solve one of the big challenges for customers, which is that first out of the box, I want to spin my motor. So with InstaSPIN-BLDC and our new DRV8301-Kit, you will instantly be able to spin your motor. So have a lot of fun. I know I'm having fun with this. And if you do something really cool, I want to see how fast you can spin your motor, see what kind of systems you can build using this GUI, and feel free to post them on our EDE forum, and we'll give you some good feedback. Thanks a lot. Enjoy spinning your motor.